Here we
We're
go.
making good progress.
Okay, problem 15.
Problem 15.
Write the augmented matrix and the coefficient matrix of this linear system. So 2x plus 5y equals 7, and 5x minus 2y equals minus 3. Okay, so there's something called an augmented matrix and there's something called a coefficient matrix. Augmented matrix is the coefficient matrix plus a column for the constants. So what are the coefficients? 2, 5, and the constant is 7. And for the second equation, the coefficients are 5, minus 2, and the constant is minus 3. And that is the augmented matrix. The augmented matrix. The coefficient matrix is the same thing as the augmented matrix, but without the constant column. So that would be 2, 5, 5, and minus 2. In other words, those are just the coefficients.
So it's just the coefficient, isn't the, because they're the coefficients, they're not the, okay.
This is the coefficient matrix. And that's all there is to problem 15, is just write down the coefficient matrix.
How many points was number 15?
I think that was like 4 points. 2
4 points?
4 points total.
4 points total, 2 and 2?
Yep.
Okay.
Oh, and it says on the back what the total.
That's number 15?
Yeah. You can check. Number 15 is... Oh, number 15 was only 2 points. I only gave 1 point for each because it was such a simple question.
Because you marked my whole thing wrong there, okay.
Okay. All right, now we come to 16. 16 is solve this system of equations. Hey, Kyle. Using Kramer's rule. Now we get into Kramer's rule. Okay. So, for Kramer's rule, you don't need the coefficient matrix. You don't need the augmented matrix. Don't need the augmented matrix. Okay. So here's our linear system of equations, and we start off with the coefficient matrix. And I'm just going to call that the A matrix, to give it a letter. Okay. So the first step in Kramer's rule is to calculate the determinant of the A matrix. Well, what is the determinant of the A matrix? It's the product of the diagonal elements minus the product of the off-diagonal elements. So that would be minus 4 and minus 25. Minus 29. So that's the determinant of the coefficient matrix. That's step 1 in Kramer's rule, always is. Now step 2 in Kramer's rule is to compute the determinant of something that I call, this is just my personal choice of symbols, the big X matrix. I'm not saying this is X, I'm saying this is the matrix that I'm going to call big X. And what is the matrix? Well, it's the coefficient matrix where I replace the X column with the constants. That's what Kramer found out. So I'm going to write this as 7 minus 3, and then the Y column stays the same. So to get the big X matrix, I just replace the X column with the constants. And now I calculate the determinant. So that's minus 14 minus a minus 15, which is minus 14 plus 15, which is 1. Okay. And now I'm going to calculate the determinant, what I call the big Y matrix. The big Y matrix. It's not Y, it's just the matrix that I'm going to call big Y. And that's the determinant of, again, the coefficient matrix where I replace the Y column with the constants. So I'm going to leave the X column alone. Oops, leave the X column alone. That's 2 and 5. And the Y column I'm going to replace with the constants, 7 and minus 3. Well, what's that determinant? Well, that's minus 6 minus 35, which is minus 41. Okay, I now have everything I need to tell you what X and Y are. I've got the determinant of the coefficient matrix, it's minus 29. I've got the determinant of the big X matrix, which is 1. and the determinant of the big Y matrix, which is minus 41. So X is equal to the determinant of big X divided by the determinant of the A matrix. But I know what those are. That's 1 divided by minus 29. That's X. Y is the determinant of the big Y matrix divided by the determinant of the A matrix. Oops. Getting messy. Oh, that's terrible, terrible writing. Determinant of the A matrix. But I know the determinant of the big Y. It's minus 41. And I know the A matrix minus 29, so that's 41 over 29. So that's X and Y. So the solution, if you want to think of it this way, is minus 1 over 29 divided by 41 over 29. That is that's Kramer's rule. And so you've seen it a number of times. I mean, you've seen it in the PowerPoint slides. You've probably seen it in your homework. It always works the same way. You write the coefficient matrix, get its determinant. That's going to be the denominator of your answer. And then you're going to replace the X column and the Y column one at a time. When you replace the X column with the constants, you're going to get a determinant that's going to determine the X value. When you replace the Y column with the constants, and take the determinant, you're going to get a number that's going to determine the Y value. And there's just these ratios. So it's one of these things you've got to do it a couple of times, and it'll be yours. And it works for 3 equations and 3 unknowns, or 1,000 equations and 1,000 unknowns. Works all the time. Yeah, I think that's all I want to say about that.
Write it down.
Okay, and you'll be able to see this in the video. All right, so that's problem 15 and 16. So we move on to 17.